Okay, students, so today we are going to look at an example which will illustrate the use of work energy theorem. Meaning, I am going to use the work energy theorem to try and solve this question. So the example which I am referring to is a question which had come in JEE Mains 2013, which you can see it on your screen. So let me just zoom into this. What you can do is you can take a screenshot of this, okay, and then we'll try to solve this question. So why specifically I have taken this JEE Mains 2013 question is because this question has been solved incorrectly in various doubt solving websites which you see nowadays. So I thought maybe let's try and correct that. At the same time, you'll also see how to use the work energy theorem in solving this question. So if you read the question, it states that a 70 kg man leaps vertically in air from a crouching position. To take the leap, the man pushes the ground with a constant force F to raise himself. The center of gravity rises by 0.5 meters before he leaps, okay, and after he leaps, the center of gravity rises by another 1 meter. So in this example, you have to find out the maximum power delivered by his muscles, okay, and there are 4 options. So let's see if we can work out this example. So what I've done is I have already drawn the free body diagram. So let me take you to that. So this is the man, okay, and let's see how this works out. So if you see in the diagram, I have already drawn the free body diagram. So you have the man in which there are 2 forces, namely, if you see, so first this is his crouching position. So let me write this. This is the crouching position. Okay, this is when he is just about to leap, and this is when he has reached the maximum height. So if you see in the crouching position and when he is just about to leap, his feet are in contact with the ground. Okay, and obviously once he leaves the ground is when his feet are not in contact with the ground. So while he is grounded or while his feet are in contact with the ground, you will see the forces which are acting on him will be F. This F is nothing but a normal reaction. Okay, so since in the question they have given F, I have written F itself, but you should know that this is the normal reaction which the ground puts on the man. The second is, of course, your gravitational force mg, and I have also marked the center of mass. Okay, so let's say initially the center of mass is at this position, and then while he is leaping, the center of mass will come slightly up, and the distance between them is 0.5 meters, right? And of course, this is your n. And finally, when he leaps, so this is the position of maximum height. So in the position of maximum height, you will see that the center of mass has risen by a distance of 1 meter as given in the question, and from the crouching position to leap position, it has risen by 0.5 meters. Okay, so this is the question as it stands. If you see the difference, when once he in air, the only force which is acting on the man is the gravitational force, okay, mg. So that you need to know. There will be no normal reaction, and there is no force F, because that can be only be applied by the ground on the man. So in the last case is where the force F or N is absent. So this is what you should note over here, and for convenience it is stated in the question that the force F is a constant. So now let's write the work energy theorem and see how to use it. Okay, so if you see in this question, what we need to do is, if you have read that, we have to find out what is the maximum power. Okay, so let's do that. So your P max, so your maximum power is your force. So power is force into velocity. So therefore maximum power will be force into maximum velocity. What about force? So they have already given that the force is constant over here. So you don't have to do much for that. So all you need to do to find out the maximum power, you need to find out V max, and you have to find out the force. So therefore we will have to solve this in two iterations. So namely will have to use the work energy theorem in two iterations, or we will have to use it twice, so that in the first time we will get the maximum velocity, and in the second time we'll get the value of force. So we multiply the two, and from that we get the maximum power. So if you see, let's first write down the work energy theorem. Okay, so this is your work energy theorem. So work energy theorem I have already proved and demonstrated in the previous class. So if you have not seen that video, I would request you to see that video first, and then you can come over here. Right? So the work energy theorem states that the change in kinetic energy. So therefore change in kinetic energy will be half mv final square minus half mv initial square. So initial velocity, and so that is equal to the work done. Right? So this is your work energy theorem. So here if you see, since we are looking at the final velocity and the initial velocity, so you have to describe the event. So what is your initial event and what is your final event? So that is very important. So here to solve this, we are going to take the leap stage. So this is the initial stage. Okay, so when he's just about to jump, and when he's just about to jump is where his feet are just not touching the ground. So the only force acting on him at that time is mg, and the final position is the maximum height position. So when he is above the ground, and where if you see, his velocity will be zero. Why his velocity will be zero? Because this is the position of his maximum height, so he cannot go any further. So since he is not able to go any further, you should know the velocity over there will be zero, and when he is about to leap is where his velocity will be maximum. Okay, so these are the two events. So the initial is the place where he leaps, and the final is the place where he reaches the maximum height. So let's plug in the values over here. So as I told you, the final velocity is 0. So this is the point where he has reached the maximum height, and his initial velocity is v max square, which we are going to find out. We need to find out v max so that we can find out the maximum power and the work done. So as I told you, between the leap and the maximum height stage, the only force acting on him is gravity. Please understand, at the time when he just leaps, his contact with the ground ceases, so therefore there is no F acting on him. So this is how you need to understand that. So therefore it is only gravity which is working between the leap and the maximum height stage. So we write the gravitational force mg into the distance which he has covered. So that I have already marked over here. You can see that I have already marked over here. The center of mass rises by a height of 1 meter. Okay. So here the displacement is 1 meter. So let's write me 1. There's one more thing which you need to add. So work done is always the force into displacement into cos of the angle between the two, the force and the displacement. Since the force is downward but he is moving upward, so the angle is 180 degrees. So therefore the work done by gravitational force will be negative. So the first term vanishes over here, so we get minus half mv max square. Okay, and you will get a negative mg. So this is your negative mg, right? So this m and m will get cancelled. So therefore we now get the value of v max. So v max will be square root of 2g. So therefore now from using the work energy theorem, we have got the value of v max. So v max will be equal to square root of 20. If anything you don't understand over here, I'll be happy to repeat, but you kindly leave your comment in the comment section, so I will understand that which part you have not understood or which part I need to do it again if required. Right? Okay, so far we have solved 50% of this question. We have got the maximum velocity, which is equal to square root of 20. Now as I told you, the second part which we need to do is over here. So we have calculated the value of v max, right? So this is, let me just write it over here, this is square root of 20, and now the other part is where I need to find out this force. okay, which is a constant as given as given in the question. So for that, again I am going to use the work energy theorem, but with a small change, meaning I am going to change my final and the initial event. Okay, only then you will be able to find it out. So you can't say I will use the same event and then try to find f. So this you have to do it very smartly. So this is all how the question is all about. So now we are going to use again the work energy theorem, but now my initial event is when he is crouching. So my initial event is when he is crouching, and the final event is where he has reached the maximum height. Okay, so let's take. Okay, so we are again going to use the work energy theorem as I said, but here we are going to take the two events differently. So this is my initial event. As I said, the initial event is my crouching position. So let's write that. Now what is the velocity over here? So write down the velocity. So velocity over here we know is 0, and the final position is this position, the maximum height position. So maximum height position which he reaches, and the velocity over here is again 0. So please note all these things very carefully. Okay, so don't get confused. And what is the height which he travels from the crouching position to the maximum height position? So if you see the distance, the center of mass travels is 0.5 meters. So this distance plus a distance of 1 meter. Okay, so the total distance traveled is 1.5 meters. So the distance traveled by the center of mass. So center of mass travels a distance of 1.5 meters. Okay, fine. Now the second part is, if you see the force. Now for what distance is the force acting, or for what distance is the normal reaction acting? So if you see in the diagram, the force acts on him only from the crouching to the leap position and not from the crouching to the maximum height position. So if you see, the force will act only from the crouching to the leap position, which is a distance of your 0.5 meters. Okay, so understand that the gravitational force acts right from crouching to maximum height, whereas the force acts only from crouching to leap. So the distance for which the force acts, so force acts only for a distance of 0.5 meters. Okay, so this will be very necessary while calculating the work done. So there are two forces involved over here from the crouching to the final leap position. Okay, and those two forces are gravitational force and the normal force, or the force F. So first let's write down this. So your half m v final square minus half m v initial square, okay, will be equal to, here you will have to, since there are two forces involved, you will have to write this as work done by all forces. So work done by all forces. And which are the forces? The forces involved is F, and the forces involved are mg. So you have to account for the work done by both the forces. So let's go to the LHS side. The LHS side, I told you the final velocity is 0, so I don't have to look at this term. So this will be 0. The initial velocity is also 0. So look at the event again. So I'll show you the event again. The initial is crouching. So what is the velocity over here? 0. What is the final position over here? The maximum height position. What is the velocity over here? So velocity over here is also 0. So these are the two positions which we are looking at. Okay, and now we have to look at all the forces acting between the initial and the final position. So those two forces are namely F and your mg, right? The force F acts for a distance of 0.5 meters, as I have shown you in the diagram, and the gravitational force acts for 1.5 meters. Okay, which I have also shown you in the diagram. You can take a look at this again. So I'll repeat it for your sake. The force acts from the crouching position to the leap position. So the distance is 0.5 meters, and the gravitational force acts from the crouching to the maximum height position, which is the distance of 0.5 meters plus 1 meter. Fine. Okay, so now let's populate the right hand side. So right hand side you have force. The distance for it works 0.5 meter. Now what is the angle between the force and the displacement? they're acting in the same direction, so cos 0. So always look at the directions also, right? So the force will do a positive work. However, gravitational, if you see, so you have a mg, you let's write the distance for it which it works 1.5, but they are, if you see, in opposite direction. If you see, the gravitational force is downwards like this. However, the center of mass is moving upwards like this, right? So what is the angle between the two? 180 degrees. So that I need to add. What will happen once I add 180 degrees? If I put cos 180 degrees over here, so we are going into negative work done. So the work done by force F is positive, whereas the work done by the gravitational force is negative. So now let's again look at this. So 0 will be equal to F into 0.5. This is positive, and negative of mg into 1.5, right? So now we get the value of force. How? So therefore your force F will be equal to mg into 1.5 divided by 0.5. So I get F is equal to 3 mg. Now this is again a very important part, okay, in this question, because you will not find this. Many of the website I've seen, the doubt solver website, they have given F is equal to directly 2 mg, which I feel is incorrect. So that is not right. Okay, in this case, as per the distances involved, the force has to be 3 mg. Okay, so take a note at it. And then finally, once we have got the force, now all I have to do over here is substitute this in this value to find out P max. So P max will be my force, which I have just calculated over here. If you see, the force over here is 3 mg, right? And V max is what I have already calculated. So let me just put in, just plug in the values. So my P max, so this is 3 mg, right, into square root of 20. So this is what we have to get, and finally we can write down the answer. So this will be 3 into, now they have given the weight as 70, we take the value of g as 10 as given, into square root of 20. So if you multiply this 3, then you will get P max. So that will be 9.39 into 10 to the power 3 and power, so this is watts. So this is how we get the final answer. So I think this is the fourth option over here. So I hope students you have liked this video, and I have been able to demonstrate a very important concept, which is the work energy concept, in solving some of your JEE main question. If you want me to solve any other question which is in your mind with the help of work energy theorem, kindly leave it in the comment section, so I can try to solve that question in the next class. So till then, kindly stay tuned into my channel. I'll be I'll be bringing many more concepts like the work energy theorem, okay, then the energy conservation concept, and many more such things in my next classes. So you can get a good idea as to how to use this, and as well as keep your concepts very crisp and clear. Okay, so thank you, students.